Hello children, you're welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and today it means it is revision time. Hi, I'm Uncle Agbaje. Today in mathematics we will continue our work on revising the previous topics that we have learned. But first, the objective of the lesson, which will still be for you to be able to recall all that we have learned, important points from there. So let's just get right into it. First question today says, starting from where we stopped in the last lesson, what is the value of x in the diagram below? I'll give you some time to think about this and we'll see what the answer is. I have seen the answer and I believe you should have by now. Let's see what that answer is. The answer should be 35 degrees. And why is it 35 degrees? Now, that is because this is already 110 degrees. In a triangle, there are 180 degrees. So if I remove 110, I'm left with 70 degrees. Now, this is x and this is x, and that means that they are equal. So I divide 70 into two equal places. 70 divided by 2, I'll get 35 here and 35 here. Telling us that x is 35, as we have seen. The next question says, what is the value of x and y in the diagram below? This is quite a complex one, so you want to take your time and do it. I'll give you time. You might want to start from finding x and then using it to find y. You should be getting your answer right about now. So, let us see how that is worked out. The answer is x is 60 and y is 50 degrees. How come? Because angle on a straight line is 180 degrees. Remember, a semicircle, 180 degrees. Now, from this point to this point, we have been told is 120 degrees. So the remaining will be 60 degrees. Now, inside this triangle, we have 70, 60, and y. Now, angle in a triangle always will give us 180 degrees. So if 70 is added to 60, we get 130. So the rest will be 50 degrees to complete 180 degrees. And that's how we got x to be 60 and y to be 50 degrees. Let's check out the next question. Arrange these polygons in ascending order of number of sizes. Do you remember the names of your polygons? Well, check this out and try to arrange them in the order of number of sides, from the smallest number of sides to the largest number of sides. Heptagon, hexagon, octagon, pentagon. I have seen the answer here and I believe you should have as well. Correct answer is this order. Why? Because a pentagon has 5 sides, an hexagon has 6 sides, an heptagon has 7 sides, and an octagon has 8 sides. So this arrangement is the correct one. Let's just see what the next question is saying. A regular polygon has 10 sides. Don't forget that a regular polygon is one that all the sides and all the angles are equal. Now, a regular polygon has 10 sides. How many lines of symmetry will this polygon have? You should know the answer already. There is no calculation involved, because one of the things that we learned in the previous lesson is that the number of sides for a regular polygon is the same as the number of lines of symmetry. So in this case, 10 sides equal 10 sides of symmetry. This question says, a regular polygon has 8 sides. How many triangles can you find in it? You should also have gotten the answer by now because there is no calculation involved. Well, the correct answer to this will be 6 triangles, and I will show you why that is. Remember that we said that a polygon, when you have n number of sides, the number of triangles would be to subtract 2. So if you have 8, number of triangles will be to subtract 6. But I'm just going to show you. Let's see if I can replicate a polygon here, an octagon, which is an 8-sided polygon, then joining this, joining this, joining this, and joining this. Okay, you have to manage my octagon. Now let's join the angles. Oh, pardon me. Yes. So, okay. So, now, joining this and joining this. Now, to join, we have one triangle here, two triangles here, 3, 4. And let's count. 1, 2, 3, 4, 4, 5, and 6, confirming that there are actually 6 triangles in an 8-sided polygon. I believe you remember this from our previous lessons. Now let's move on. Which of these is not true about prisms? Do you remember prisms? Read the statements. They have a flat top and a flat base. The top is the same size as the bottom, the base. They are flat. They are solid shapes. One of them is not true. One of them cannot be a property of a prism. Do you know the one that it is? Well, let's see. The correct answer should be that they are flat. Prisms are not flat. They are solid shapes. Flat top, flat bottom, and the flat top and flat bottom are the same, and the sides are straight. So prisms are not flat. Let's move on. Which of these is not a prism? Now the pictures are not here on purpose. So you know what a cube is: a cuboid, a cylinder, a rectangle. One of them is not a prism. You should have identified it by now. The one that is not a prism, of course, is a rectangle. Why? Because a rectangle is a flat shape, it's a plane shape. But all these are solid shapes. Cubes, solid; cuboid, solid; cylinder is also a solid shape. So a rectangle is not a prism because it is flat. Let's move on. Which of the following object is a prism? Now, which one is a prism? You have a kettle, a matchbox. You know what a kettle looks like. So the pictures are not here on purpose. A kettle, a matchbox, a protractor, which you use for measuring angles, and a chair. Remember what a prism is? Flat top, flat bottom, straight body. Now, the correct answer here should be a matchbox, because a matchbox has a rectangular top and rectangular base, and the sides are straight. A kettle, no, the bottom and top are not the same. A protractor is flat, so it's not even a prism to begin with. And a chair is not even a regular shape, you know. So the correct answer is a matchbox. It's a prism. Let's see. A circular prism is, what is a circular prism? What is that shape that has a circle at the top and a circle at the bottom and has straight sides? Well, I'll take the liberty of drawing it for you. Circular top, circular bottom, straight sides. You've seen the answer already. The answer is a cylinder. So I believe that is what you selected as well. This question says the flat part of a solid shape is called what? Now you have options. Is it a face? Is it an edge? Is it a vertex or a base? The flat part of a solid shape. You should know the answer by now. The answer is a face. And the flat part of a solid shape is a face. Let's see the next question. This question says, this is a square-based pyramid. How many faces does it have? Now, you've seen this diagram before in our previous lesson when it was rotating. So now you have the front view or the top view. So count the number of faces. All right, the correct answer should be 5 faces. And these are the 5 faces. I'll show them to you. This is 1 face, this is 2, this is 3, this is 4. Then the bottom is at the other side, and that is the 5th one. Moving on. What is the cross section of this shape? Don't forget that the cross section is the shape you get, the plane shape that you get when you cut a solid shape in the middle. So if you cut this shape in the middle, what is the cross section? You should have seen it by now. Well, I have seen it and I'm going to show it to you. It's a triangle. And why is it a triangle? Because if I cut this in the middle, well, this is a triangular prism. The front is a triangle and the back end is also going to be a triangle in this form. Yeah, something like this. Yeah. So front end triangle, back end triangle. So if you cut it along the middle as well, you will still get a triangle in the middle. So the cross section is a triangle. Moving on. This is a rectangular prism. How many edges does it have? Like your matchbox. So if you can quickly pick one and count, good for you. I'll give you some seconds to think about it or to count. And now I'll stop you. Let's see how many edges it has. It has 12 edges. Let's count. So you can see. Now, the edges, remember, are the straight lines. So this is 1, 2, 3, and 4. And of course, on the other side, there will be another 4. This is 5, 6, 7, 5, 6, 7, 8, 9. Now, there will be one at the back here, 10, 11 joining this one, and then the one coming down like this, 12. I hope I get the diagram right. This is exactly what a box looks like. So you have 12 edges on a rectangular prism. So now moving on. Now the next question says, which of the following is a pyramid? It's a visual question, so the answer already stands out. Can you pick it out? The one that's a pyramid? Well, it is this one. Pyramids have a pointed top, and if you look at all these diagrams, it is only this one that has a pointed top, which is this one. All these ones have flat top, flat top, flat top, but this one has a pointed top, and that is one of the things we use to identify a pyramid. Let's see what the next question is about. Now, scale drawing. In scale drawing, which of the following is not true? I'll read out the options. First option says, the real distance is less than the paper distance. Second option, the paper distance is less than the real distance. Third option, the scale compares the paper distance to the real distance. Last option, the real distance is larger than the paper distance. Which of these is not correct with regards to scale drawing? I believe you should have picked the answer out now. The correct one will be the real distance is less than the paper distance. That's not true. Real distances are much larger than the distance that you have on paper. If the distance between two towns is just the length of this pen on paper, in real life, it could be as long as going from Lagos to Kano. So you remember that story that I told you about that boy who told his father that he wanted to go for a drive from Lagos to Kano? So this is not correct. So let's see. Now the next question says, the scale of a drawing is 1 to 50. And you recall that the scale means how many times the real distance is larger than the paper distance. So in this case, the real length is going to be 50 times larger than the paper length. Now it says the scale of a drawing is 1 to 50. The height of a door is 7 centimeters. What is the real height of the door? You know what to do. This paper height is 7 centimeters. Real height? Well, I'll tell you the answer. Let's say you should have the answer by now, but I'll just tell you. It's going to be 350 centimeters. Why is that? Because the paper distance is just 7 centimeters, but the real distance will be 50 times larger, and that means 7 centimeters times 50 is the real distance. 7 times 5 is 35. Add that 0 to it. You have 350 centimeters. That is the correct answer. I believe you got that right. So let's move on. A block of building is 150 meters long. How long will the same length of the building be on a plan drawn to a scale of 500? Now, we know the real distance, 150 meters. We want to calculate the distance on a plan, which is a paper. So, you know what to do? Do it quickly. Well, let's see what that answer will be. It's going to be 30 centimeters. But how did we get 30 centimeters? I'll just show you. The real distance is 150 meters, and it is 500 times larger than the planned distance. At least that's what the scale is telling us. So to get the planned distance, you have to scale the real distance down because the paper distance will be smaller. And to scale it down means to divide by 500. That's 150 meters divided by 500. Now, to make this division easier for us, we're going to change this meters to centimeter. And you do recall that 1 meter is 100 centimeter. So 150 meters will be 100 centimeter, or 15,000 centimeters. Now you divide by 500. So 2 zeros cancel 2 zeros. 5 goes here 1, 5 goes here 3, here 0. You still have your centimeter, and that's how we get 30 centimeters. Our final answer. Let's move on. Ade scales down the height of a tree by 100. He scales it down by 100. In his drawing, the new height is 7 centimeter. What is the original height? Now you know the height on paper, 7 centimeter. What is the original height of the tree? Are you going to scale up or are you going to scale down? Well, do what you will do, and let's see if you'll get the answer. You should have that answer by now, because, my friend, it's not so difficult. Let's see what the answer is. It's 700 centimeter. Why? Because if the paper distance is 7 centimeter and the scale is 100, then we have to scale the paper distance up. And to scale up means to multiply by 100. 7 centimeter times 100 will give you 700 centimeters. That is your answer, my friend. This question says, if 2 centimeters represent 7 kilometers on a map, if 2 centimeters represent 7 kilometers on a map, what distance will 6 centimeters represent? This is quite intuitive, so just think about it. Now let's see how that is done. First, the correct answer will be 21 kilometers. How did we get that? Well, it's quite simple. 2 centimeters is 7 kilometers, or let me say, represents 7 kilometers. Another 2 centimeters represents another 7 kilometers. Another 2 centimeters represents another 7 kilometers. Altogether, 6 centimeters will represent, add everything here, you get 21 kilometers. That is it, my friend. Let's see what the next question is saying. And this is our final question for the day. Scale drawing is not applicable to which of the following? I mean, scale drawing, we use it in many fields, like I have taught you. It's applicable in many fields of human endeavor. But it is not applicable in one of these fields. Which one is it? You should have picked it out by now. And that field is music. We do not need scale drawing to sing, but we need it in map reading, we need it in graphic designing, and we need it in architecture. So that's it for our revision class for today. I believe you have been able to recall 1 or 2 things that you have learned in the course of our mathematics lessons on the classroom in your home. I will now hand you over to Uncle Popo to bring you up to speed